AudioJungle.
Vertical controls are used to position and scale the waveform vertically, set the input coupling, and adjust other signal conditions. The vertical position control allows you to move the waveform up and down, so it's exactly where you want it on the screen. We can also drag the waveform directly to change the vertical position of the waveform. The words per diversion setting is a scaling factor that varies the size of the waveform on the screen. For example, if the words per diversion setting is 1 volt, then each of the 10 vertical diversions represents 1 volt, and the entire screen can show 10 volts from bottom to top. If the setting is 2 volts per diversion, the screen can display 20 volts from bottom to top, and so on. The maximum voltage you can display on the screen is the volts per diversion setting times the number of vertical diversions. Tap the channel icon to open the channel menu, which includes channel waveform inversion, channel coupling model, probe type, probe attenuation factor, channel bandwidth limit, and vertical expansion reference. Most oscilloscopes have an invert function that allows you to display a signal upside down. That is, with low voltage at the top of the screen and high voltage at the bottom. Coupling means the method used to connect an electrical signal from one circuit to another. In this case, the input coupling is the connection from your test circuit to the oscilloscope. The coupling can be set to DC, AC, or ground. DC coupling shows all of an input signal. AC coupling blocks the DC component of a signal so that you can see the waveform centered at 0 volts. The AC coupling setting is handy when the entire signal is too large for the voltage per diversion setting. The ground setting disconnects the input signal from the vertical system, which lets you see where 0 volts is on the screen. With grounded input coupling and auto triangle model, you see a horizontal line on the screen that represents 0 volts. And also don't forget to set the probe type and attenuation coefficient according to your probe. When measuring with a probe, the correct measurement result can only be obtained by setting the correct probe attenuation ratio. When probe attenuation ratio is changed, the corresponding attenuation ratio must be set on the channel menu to ensure the correctness of the waveform amplitude and measurement result displayed by the oscilloscope. Now let's see this bandwidth selection box, which could limit the bandwidth of the oscilloscope. Full bandwidth allows signals of all frequencies to pass. 20 megabandwidth means only signals with frequencies below 20 MHz are allowed to pass, and signals above 20 MHz are effectively attenuated. High pass means only signals above the lower limit of the currently set frequency are allowed to pass. Type megahertz and kilohertz to select the frequency scale. Drag or tap the slide bar for coarse adjustment of the maximum frequency allowed to pass. Type plus, minus buttons to precisely adjust the frequency. Low pass means only signals below the currently set frequency upper limit are allowed to pass. By limiting the bandwidth, we reduce the noise that sometimes appears on the displayed waveform, resulting in a clear signal display. The last is vertical expansion reference. Click the center, the oscilloscope waveform will be expanded with the screen center as a reference. Select the 0, the oscilloscope waveform is expanded with the waveform 0 point as a reference.